So good evening to all of you. Today we are going to solve the problems on initial conditions. Initial conditions. So what is meant by initial conditions? Initial conditions are normally exist in a network at the time of switching operation. So very simple. Problems on initial conditions are very simple. Provided you should know at t is equal to 0 is the reference period. At t is equal to 0 just before దీన్ని మనం ఏమంటామంటే జస్ట్ బిఫోర్ స్విచ్చింగ్ ఆపరేషన్ అంటాం. జస్ట్ బిఫోర్ స్విచ్చింగ్ ఆపరేషన్ దీన్ని మనం ఏమంటామంటే t ఈజ్ ఈక్వల్ టు 0 మైనస్ అంటాం. దెన్ వీ విల్ హ్యావ్ t ఈజ్ ఈక్వల్ టు 0 ప్లస్ ఆఫ్టర్ ఆఫ్టర్ switching operation అంటాం. just after switching operation. These two things you should be know thoroughly and perfectly. Then only you are going to solve the problems on the initial conditions. Okay, so very well you know about the concept. Say very well you know whenever the resistance we have connected, so there is a resistance will be there at t is equal to 0 plus, because current will be instantaneously changes when the voltage will be changes. At the same time we are having an inductance. Inductance represent L. Inductance will be act as a open circuit. L will be act as a open circuit because inductor does not allow the sudden changes in the conductor. Inductor does not allow sudden changes when the current will be flows through the inductor. Okay, next we are having the capacitance. See, capacitance will be act as a short circuit. And because capacitance does not allow the sudden variation of the voltage. Okay, because it requires the infinite amount of the current must be passing through the capacitance. Because of that reason, initial condition t is equal to 0 plus, ultimately the capacitance will be act as a short circuit. This is the important points what you need to be know. Okay, at the same time, if the inductance carry the one current source, ultimately you will have one current source. If the capacitance is carry one voltage source, that is V0, so we will have the plus and minus, there is a voltage source will be there. This is what the important thing what you need to be understand. Okay, now come to the point. I have already given this chart to you people in your notes, so keep it with that notes with you people. Now we are going to solve the problems on the first problem, that is question number 1. We are having the in the given network shown in below figure A, when the switch S is closed with zero initial current, find the value of the I and di divided by dt and d square I divided by dt if R value is 10, L is equal to 1 Henry, V is equal to 10 volts. So this is what the first problem what I was given to you people for my notes. So when the switch S is closed, normally when the switch S is closed, when the switch S is closed, when the switch S is closed, okay, when the switch S is closed, the equilibrium equation normally is given by the equilibrium equation normally is given by what is the equilibrium equation? When the switch S is closed, then the current will flows. Okay, normally we will have I into R plus L into di divided by dt is equal to V. So this is your equation number 1. If you know this equation, half of the problem is completed. Now what we need to do, okay, when the switch S is closed with zero initial current in the inductor, there is no current will be flows in the inductor. You know very well at t is equal to 0 minus, what is the S is when the S is closed, okay, that is t is equal to 0. What is there at t is equal to 0 minus? 0 minus, how it will be the condition when the 0 minus, what is the condition? So when the condition is I of 0 minus is equal to 0, there is no current will be flows in the inductor. Suppose at t is equal to 0, you have closed the switch, then at t is equal to 0 plus means just after the switching the circuit will be this circuit completely will be behaves as a like this. See, when you have closed the switch, t is equal to 0 plus means it will take 1 minute or 1 second or 2 second period of time. So how we are going to write this equation at t is equal to 0 plus, how the circuit diagram how it will look like? No, this will be like this. See, we are having V, t T is equal to 0 minus I of 0 minus is equal to 0. He himself has given 0 initial current in the inductor. Previously there was no current. When switch S is closed, the equation is like this. Okay, now T is equal to 0 plus. So now T is equal to 0 plus means the circuit has been closed, the switch has been closed, and resistance will be retained same, R will be retained same. Inductor will be act as what? Inductor will be act as a open circuit. L will be act as a open circuit. When open circuit is there, I of 0 plus, current will be what? Current will be T is equal to 0 plus. What is I of 0 plus? I of 0 plus is equal to 0 because it is a inductance will be act as a open circuit. Inductance will be act as a open circuit. So I of 0 plus is equal to 0. This is the first value. This is 0 amps. 0 amps. So first one is completed. We have found. Now come to the point. I need to calculate the dI divided by dt. dI divided by dt I need to be calculated. So how to calculate dI divided by dt? It's very simple. See here, we are having the equation. So the equation is R into I plus L into dI divided by dt is equal to V. Okay, is equal to V. So in terms of I of t, if I write the equation R into I of t plus L into d by dt into I of t is equal to V. So at t is equal to 0 plus, you are writing the equation at t is equal to 0 plus. So R into I of 0 plus L into d by dt into I of 0 plus is equal to V. What is R? R is what? R is 10 ohms. So 10 into I of 0 plus. I of 0 plus is what? I of 0 plus is 0. I of 0 plus is 0 plus what is L? 1 Henry. 1 multiply with di of 0 plus divided by dt is equal to V. What is V? V will be 10. V will be 10. Therefore 10 into 0 is 0. So di of 0 plus divided by dt is equal to 10 amperes per second. 10 amperes per second. So you need to write like this. Very, very important. Very simple problems you can solve like this. First of all, so di by dt we need to be calculated like this. First of all, understand the problem when the switch S is closed with zero initial current. Zero initial means there is no current will be flows in the inductor. Okay, so T is equal to 0 minus T is equal to 0 minus I of 0 minus is 0. Okay, when T is equal to 0 after closing the switch, okay, T is equal to 0 plus, we are having V, S has been closed, or inductor initially it will act as a open circuit. Inductor will be act as a open circuit. Therefore at T is equal to 0 plus, I of 0 plus is equal to 0. So I of 0 plus is equal to 0 amperes. Now come to the point, I need to calculate di divided by dt. So di divided by dt ela calculate chestam? Take the equation I into R plus L into di divided by dt is equal to V. From this equation, what we have done in terms of I of t, I have written the equation. So at t is equal to 0 plus, just I have substituted t is equal to 0 plus, and I have substituted the value in place of t. I have substituted the 0 plus. So R into I of 0 plus L into d by dt into I of 0 plus is equal to V. So 10 into 0 plus L value is 1 into di divided by dt of 0 plus is equal to 10. So di of 0 plus divided by dt, you are having 10 ampere per second. Now I need to calculate what? d square I divided by dt square. d square I divided by dt square. So to find d square I of 0 plus, because I need to find out at t is equal to 0 plus. So divided by dt square I need to find out. So here I find out I need to differentiate equation 1 with respect to time t. I need to differentiate this equation with respect to the time t. If I differentiate, what I am going to get? R into di divided by dt plus L into d square I divided by dt square is equal to V. With respect to the V, I will with respect to the t time period, V will be 0. So now what is the value of R? R value will be 10 ohm. I need to be write it as at t is equal to, okay, let us say I will write it like this: d divided by dt into I of t plus L into d square I of t divided by dt square is equal to 0. So in place of what we say that I of t, I need to substitute the 0 plus. I need to substitute the value of 0 plus. So let us say I will write it here. I am going to write it here. I will write it here. So here at t is equal to 0 plus, at t is equal to 0 plus, when we substitute the value of t is equal to 0 plus, r into d by dt into I of 0 plus, okay, plus L into d square divided by dt square into I of 0 plus is equal to 0. Now what we need to do? Just substitute the value of r. R value will be 10 multiply with what is the value of di divided by dt. You have got this value. Like I said, 10 amperes. You have got this value 10 amperes. So I will write it as here 10 plus the value of L will be 1 multiply with d square I of 0 plus divided by dt square is equal to 0. So d square I of 0 plus divided by dt square is equal to 10 into 10 will be minus 100 ampere per second square, because it is t square. So this is the answer. This is how you need to solve the problems on RL circuit. Okay, first of all we should know with zero initial conductor, with zero initial current in the inductor. So zero initial means, okay, initial condition itself t is equal to 0 minus the condition is 0. I of 0 minus is 0. When closing the switch, when switch S is closed, okay, there is a flow of current will be there. So ultimately we need to write the equation. Okay, initial condition, inductor will act as a open circuit, because there is no current will flow. There is no current because inductor does not allow the sudden changes in the current. So I of 0 plus is 0 because it will act as an open circuit. Then we need to find out the di by dt by using this equation. Then we need to find out the d square I divided by dt square into I of 0 plus by differentiating the equation 1. We are going to get r into di divided by dt plus L into d square I divided by dt square is equal to 0. R into I of t, in terms of I of t, if I write this equation, t is equal to 0 plus, I need to substitute what is the values, and then we are going to find out. After doing the simple simplification, we are going to get the value is d square I of 0 plus divided by dt square is equal to minus 100 ampere per second square. Minus 100 ampere per second square. Let us say the second problem. See here, very simple. Question number 2. There is a question number 2. He is given in the problem. In the given network shown below figure A, the switch S is closed with zero initial switch is closed at t is equal to 0. He is given like this. Switch is closed at t is equal to 0 with zero initial condition. Find. You need to be find I di divided by dt and d square I divided by dt square. He is given the circuit is given. This is what the circuit is given. Okay, so circuit, this is the switch, okay, so this is 100 volts is given. This value will be 100 volts. R value will be 10 ohm. L is equal to 100. This is what the data is given. In the given network shown below figure A, the switch S is closed at t is equal to 0 with zero initial condition. Determine the value of I di divided by dt and d square divided by dt square. As usual, when the switch S is closed, the equilibrium equation normally you are going to get. See, this is what no. If the switch S is closed, you are having R and you are having the inductor. This is V. So write the equation I of t is equal to R into L. If you write the equation, so you are going to get I into R plus L into di divided by dt is equal to V. Okay. So at t is equal to 0 plus, inductor will act as a open circuit. So inductor act as a open circuit in LR. So this is 100 volts. So when the switch S is closed, we are having the 10 ohm, but inductor will be act as a open circuit. L will be act as a open circuit. So this is what I of 0 plus sometime. Switch S is closed. So when at t is equal to 0 plus, I of 0 plus is equal to 0 amperes, 0 amperes, because at t is equal to 0 minus, at t is equal to 0 minus, even the condition, what is the condition at t is equal to 0 minus? Before, just before switching operation, I of 0 minus is 0 amperes. He himself was given in the problem with at t is equal to 0 with 0 initial condition, there was no current will be flows through the inductor. Now I need to calculate what? di divided by dt, di divided by dt. Ela calculate system. How we are going to solve di divided by dt? Very simple, very simple. Once, okay, to find di divided by dt, I of 0 plus antam. To find d divided by dt into I of 0. Very simple. From equation 1, write the equation r into I of t plus L into d divided by dt into I of t is equal to v. So at t is equal to 0 plus. So r into I of 0 plus L into d by dt into I of 0 plus is equal to v. What is resistance? Resistance is 10. Multiply with what is I of 0 plus? I of 0 plus is what? What is the current I of 0 plus? 0 plus L value will be 1. D divided by dt into I of 0 plus is equal to, what is the value of V? V value will be 100. V value will be 100. Therefore, di of 0 plus divided by dt is equal to 100 ampere per second. 100 ampere per second. Now what we need to do? I need to calculate d square a divided by dt square. So, ela calculate cheyali d square a divided by dt square. Okay, d square divided by dt square ela calculate cheyali. Very simple, very simple. So, you need to be differentiate the equation 1. I need to be differentiate to find. I will write here to find d square I of 0 plus divided by dt square. So, I need to be calculate cheyali. Ela calculate chestamu? Differentiate equation 1 with respect to t. Ela find chestam? R into di divided by dt plus L into d square a divided by dt square is equal to 0. So what we need to do? R into d I of t and rastamu plus L into d square divided by dt square I of t and rastamu. I of t is equal to 0. Now what we need to do? At t is equal to 0 plus, I need to substitute here 0 plus substitute cheyali. Ekkada t untundo akkada manam t is equal to 0 plus substitute cheyali. Okay, what is the value of r? R value will be 10 multiply with d divided by dt into I of 0 plus L value will be 1 Henry multiply with d square I of 0 plus divided by dt square is equal to 0. dt square is equal to 0. Now do the simplification, and while we are doing the simplification, 10 into what is the value of di divided by dt of I of 0 plus? You have got the value of d divided by dt into I of 0 plus is 100 amps. Just write it as 100 amps plus d square I of 0 plus divided by dt square is equal to 0. So therefore, d square I of 0 plus divided by dt square is equal to minus 1000 ampere per second square. This is how you need to solve the problem 5 RL circuit. Okay. Now, let me say question number 3. He is given in the question number 3. Very simple. In the given network shown below figure A, the switch K is closed at t is equal to 0 with 0 initial condition. Find value of I di by dt and d square I divided by dt square. The what we say that this is 8 ohm. The value of L will be 0.2 Henry. This is how he is given the problem. Very simple. As usual, what we are going to do, when switch is closed, we are going to write the equilibrium equation. Very simple. Problems on zero initial conditions are very simple, provided you should know the conditions. Okay. So when given network, when switch S is closed at t is equal to zero initial condition. There is no current in the initially there was no current in the circuit. So at t is equal to 0 minus I of 0 minus is 0 amps. I of 0 minus is 0 amps. When the switch is closed, what is the equilibrium equation? R into I plus L into di divided by dt is equal to V. That is the equation number 1. That you should not be forget, because it is a RL circuit. It is a RL circuit. So when the switch is closed, when switch is closed, what is the condition? You know, at t is equal to 0 plus. When switch is closed, switch closed them. So when switch is closed, the value of this one is 12 volts. This is 12 volts. This is 12 volts. Okay. The circuit is 12 volts, 8 ohm and 0.2 Henry. Now, switch has been closed. When the K is closed, where having the resistance will be written same, inductor will be act as a open circuit. Inductor will be act as a open circuit. This is I of 0 plus. This is R value will be 8 ohm. So there is no current flows in the inductor, because inductor does not allow the sudden changes when the current will be flows through the inductor. Therefore, at t is equal to 0 plus, I of 0 plus is equal to 0 amperes. 0 amperes. Now, I need to find di divided by dt. I need to find di of 0 plus divided by dt from equation 1. From equation 1. So from equation 1, R into R, what is the equation? R into I, okay? R into I of t plus L into di of t divided by dt is equal to V. This is the equation. Now we are finding the value at t is equal to 0 plus. We are finding the value at t is equal to 0 plus. So what is the value of R? The value of R will be 8. I of 0 plus L value will be 0.2. D by dt into I of 0 plus is equal to V. V value will be 12. V value will be 12. So 8 into I of 0 plus will be 0 plus 0.2 into d by dt into I of 0 plus is equal to 12. I of 0 plus, okay, is equal to 12. Now what we need to do? We need to do the simple simplification. We need to do the simple. 8 into 0 is 0. D I of 0 plus divided by dt is equal to 12 divided by 0.2. So probably you are going to get 60 ampere per second. 60 ampere per second. Now I need to find out d square divided by dt square. I hope you understand. T is equal to 0 minus I of 0 minus is 0 amp. When switch is closed, at t is equal to 0 plus, inductor will be act as an open circuit. So I of 0 plus is 0 amps. Now if I differentiate the equation 1, okay, if I differentiate, because to find d square I of 0 plus divided by dt square, ఇదే మనం ఫైండ్ అవుట్ చేయాల్సింది. లాస్ట్ స్టెప్. సో I need to find out, I need to be differentiate equation 1 with respect to time t. So what we are going to get? R into di of t divided by dt plus L into d square I of t divided by dt square is equal to 0. Okay. Now what we need to do? At t is equal to 0 plus, no, we need to find out at t is equal to 0 plus. When we want to find out at t is equal to 0 plus, write the equation at t is equal to 0 plus. Wherever t is there, I need to substitute the 0 plus. So R into d by dt into I of 0 plus L into d square I of 0 plus divided by dt square is equal to 0. Now what we need to do? Just substitute the values. If I substitute the values, okay, R value will be 8 multiplied with di of 0 plus divided by dt plus the value of L will be 0.2 into d square I of 0 plus divided by dt square is equal to 0. So 8 multiplied with, what is the value of di divided by dt? Just now we have found the value is 60. 60 plus 0.2 into d square I of 0 plus divided by dt square is equal to 0. So 0.2 into d square I of 0 plus divided by dt square is equal to minus 480. So d square, okay, d square I of 0 plus divided by dt square is equal to minus 480 divided by 0.2. So probably you are going to get this value. Minus 2400 ampere per second square. This is what the solution for the problem. Okay, thank you for watching this video. Thank you very much.